name is Liam. This is LED color control. So it is a optimization tool to control an array of LEDs. So when you combine LEDs, you basically add up whatever light they each produce individually. And with arrays, you can add multipliers to the power of each individual LED, which gives you a lot of control over the final light that the full array produces. And so that's what this is basically. And it's a MATLAB GUI, so hopefully easy access when you grab MATLAB. I'm just going to do a really quick summary of color science, because that's what this is based on. The human eye has 3 cone cells that sort of focus on red, green, and blue wavelengths. So those are the primary colors. But what this means is when you define colors, you have to define them in 3 dimensions to define everything correctly. And this gets us the very basic color system, which was defined in 1931 as the XYZ tristimulus values. And this is also related to the XYY color space. So color is defined by chromaticity and brightness. And in this case, this is the XYY color space plotted in 2D. X and Y lowercase are the chromaticity coordinates. And you can imagine this as a 3D plot where uppercase Y is basically analogous to brightness. So it goes in and out, and many of your colors can have the same chromaticity coordinates, but they can have different brightnesses, so they will appear different to human eye. So what I'm focusing on is how do you compare colors? So given a bunch of LED spectra or some spectra we want to match, there are lots of ways you can compare those or match them up. There are also a whole bunch of different color spaces. I've just listed a few of them here. And they also have disadvantages and advantages. There's a concept called color linearity, perceptual linearity actually. So if you have, I'll go back to this color space for reference. So if you have 2 colors, and they're separated by a certain distance on this color plot here, say it's up in the green section there, and then you have 2 more colors that are separated by the exact same distance down in the red section. If it's a perceptually linear color space, you will see the same thing, the same color shift between those 2 colors in those 2 regions. But a lot of color spaces aren't actually perceptually linear. So you can have two colors that are separated by the same distance in color space, but they won't actually appear to be different by the same amount. So that's important. And so that's where color difference comes in as an important metric for comparing colors. Because depending on the color space you're using, you might have to add modifiers to make up for nonlinear aspects of the color space and other things like that. So it can get kind of complicated, but ideally it would just be the Euclidean distance in whatever color space you're using. There are also a bunch of other useful metrics. Correlated color temperature is, you can sort of see an example here. It's basically comparing the color of the source to the color produced by a black body at a specific temperature. So you can see a lower temperature CCT is sort of a red, more yellow light. As you get higher temperature, it gets bluer. There's also a thing called CRI, which is the color rendering index. That is basically measures how a light changes what an object looks like, changes the color of an object compared to the idea which would be a natural light, like the sun. So if an object looks very red under a light, it's going to have a very low CRI, because that isn't really, well, assuming that it doesn't actually look red under the sun. So I'm going to just demo here. So here's my GUI. The first step you do is you'll import your data right here. And the data should be in the form of something you get from a spectrometer. I guess the only assumption I'm really making when I import the data is that the first column is going to be the wavelength data, and the rest can be basically whatever unit you want it to be. So I have the individual LEDs on the top graph here. Then down here is the combined spectrum of all the LEDs will produce if you put in an array. You can play with the multipliers to change the output spectrum however you want. You can write them in here. You can also say you don't want one of the LEDs after all, even though you already imported it. You can just disable it temporarily, turn it back on. And then you also have to import an ideal, which is, in this case, what you want your produced spectrum to match as best as possible. So that's my ideal. And the most important button in all this is the optimize button. But you can control how you want to optimize it. You can control based on color difference, which is these options here. You can control it to optimize so that the correlated color temperatures match. Least squares is the simplest. It's easiest to visualize here. It just matches the spectrum. That's not a very good match, but it's just going to depend on the LEDs you have and the spectrum you're trying to match. I'm still working on the optimizations for color difference, and that's a work in progress, but I was hoping to be able to show it, and I've had some trouble. So other things is you can display coordinates in a bunch of different color spaces. In this case, you plot both the coordinates for the ideal and the generated spectrum. You can get color difference. There are various kinds of color differences. Another thing actually I forgot to mention is one thing that separates color spaces is some of them are intuitive. So, for example, the X, Y, Y. Along the outside here, that's the weightings of monochromatic light. And if you say, draw a line from one wavelength to the next, you will cross every color that's been produced with those two monochromatic lights. So it's pretty intuitive if you give a coordinate. You can sort of see how it can be made, or you can see lots of information just by looking at it. Other color spaces though, like LAB, which was actually designed to be perceptually linear, so it's pretty accurate compared to a lot of them. There isn't a visualization that I can find that's easy to look at, that's useful, and it's really, LAB units are very abstract, they don't really have a physical representation. Yeah, so that's where I am right now. So the next step, this is after I finish my optimizations. I want to also add various metrics like CRI and CQE in there as well. But everything I've done so far has already been done before. The problem is most of the time it's behind a paywall. It's not open source. Companies control it because they wrote it, and it's not easy to access. This next thing, which is a similar problem, but say you have a whole bunch of different LEDs. You're working for some company that works with LEDs, so you have a whole bunch of options. And you want to design a specific fixture to meet some quality. This would choose the best of all your LEDs available to produce that based on whichever of these metrics you choose is important. So you can choose it to maximize CRI or to produce a specific CCT, that sort of thing. And this is directly applicable to designing LED arrays, and as I have been told, has not been done before, which is very exciting. So yeah. Also, if anyone's interested and knows MATLAB pretty well, I do need a mentor. I have not gotten one yet, so talk to me if you're interested. And, thanks to Professors Morthy, Goldschmidt, Professor Sandy Pine, who's with the Smart Lighting Research Center, which is where I'm also working, Sean Sullivan, RCOS, and Smart Lighting. Questions?
Does LED array mean something specific, or is it just what?
It's just a bunch of LEDs turned on together, and presumably linked up for control purposes.
So these things are all, the optimization is all done at the back end. Once you design it, you just apply the appropriate multiplying factor to the LED side.
That's right. Yeah. Yeah.
It is not, you don't control the lighting, it's changing lights, etc. So how do you vary that? I want different lighting patterns over a period of time. So you design all those parameters over time and then you apply those parameters.
Yeah, I think so.
Do you understand the question?
I'm not sure exactly. So.
Okay, I can take that.
Okay. Yeah.
I think I can clarify it, like if you want to have colors fade over time, so you
Yeah.
have like the color that you want, and then you want that to like, you want like a reddish color, but then you want it to turn blue over like 3 hours.
Okay.
Like adjust each LED to make that transition.
I mean, I haven't built in the functionality
Yeah.
for that, but you can run those calculations separately and then
Okay.
right under sort of software you can change.
Have you heard of Octave? It's similar to MATLAB, but it's open source.
No, I
It's supposed to be able
haven't.
to run the same code in MATLAB.
Okay.
Actually, Octave is the
Octave?
Yeah,
Okay.
but you should, at least you should make an attempt to, but the people have complained about Octave, but at least you should try to
Okay, yeah,
use
I'll look it up.
Octave.
Thanks.